Hi guys, this is your TK again. In this video, we are going to see how to create a conversational chatbot using Python and NLTK. First, let's import all the packages. So import NLTK, import random, import string, and import RE, Unicode data. And we need to import the wordnet from the NLTK corpus. So from NLTK dot corpus import wordnet as w1 and let us import the lemmatization. Word lemmatization from NLTK from NLTK dot stem dot wordnet import wordnet lemmatizer. Let's import the Wikipedia package also. Import. Okay, my bad. Import Wikipedia as wk from corrections. Import default so we're gonna create some default dictionary using this package and import warnings to ignore the warnings. So warnings dot filter warnings ignore and nltk dot download unat and nltk dot download wordnet to download the wordnet nltk package and let us import the tf idf vectorizer from sklearn from sklearn dot feature extraction import tf idf vectorizer. Now let's import the cosine similarity package from sklearn dot metrics dot pairwise import cosine similarity and we will import the linear kernel as well. So let me run this code. Vectorizer. Okay, from sklearn dot future extraction dot text. Okay, now all our packages has been imported. Now let's try to read a sample data. So I have something like hr.txt in my local system. So I'm going to open the text file hr.txt. I'm going to open it in a read mode. I'm going to ignore in case of any errors equal to ignore. So errors equal to ignore. So raw equal to data dot read, which I'm gonna read everything as a string, and I'm gonna convert into a lowercase raw equal to raw dot lower. Okay, so let me try seeing some of the records from here. So this is the data I have about the human resource. Now let's start with the process. So I want to tokenize it. So I'm gonna use sentence tokenizer. So sentence tokens equal to we're gonna use the NLTK package for this NLTK dot send tokenize. I'm gonna tokenize the raw data. So this is done. So now here I'm gonna write a simple function named normalize. The purpose of the function is like to remove unwanted chunk variables and make it in a meaningful format. So now let's write the same. So now I'm gonna write a function named normalize where we're gonna normalize our input data in a proper format. So normalize and I'm gonna get the user text. First let me try to remove in case of any punctuations from there. For that I'm gonna do something like remove punctuational tick equal to tick ORD of punctuation, component for and string dot punctuations. Punctuation. So now let's try to tokenize the words. So word token equal to NLTK dot word tokenize, and I'm gonna convert into lowercase, so text dot lower, and I'm gonna do the translate. Here I'm gonna pass this remove punctuation. So basically it is going to tokenize my word, and it's gonna remove some in case of any unwanted punctuations in the sentences. Now I'm gonna remove some of the ASCII values. So what I'm gonna do is like new words. I'm gonna create a list for word in this word token. I'm going to select new word equal to Unicode data dot normalize, where it's going to remove some of the ASCII characters. NFKD comma word dot encode ASCII comma ignore decode UTF-8 ignore. So now here what we're gonna do is like new words dot append new word. So we're gonna append this cleaned word over here. So next what I'm gonna do is like I'm gonna remove some tags. So in my input text data I have some unwanted tags. So I'm gonna remove that over here. So what I'm gonna do is like for W in new words, I'm gonna iterate over the new words now. So text equal to re dot sub. So I have this kind of a special character. So I'm gonna remove it from there. Okay, LT and mark. And I'm gonna append it over here. So next what I'm gonna do is like I'm gonna do the parts of speech tagging, and also we're gonna do lemmatization on top of the data. So tag map equal to default dict. So I'm gonna have this noun over here. Similarly, tag map of j equal to wn dot adj, and tag map of so I'm gonna tag it actually as a verb is wn dot verb, something like this. wn dot. Next, we're gonna do tag map on the, okay, it should be a capital. So w1 dot verb is nothing but the word not verb. So we're gonna do tag map of rs should be case. We paste it so it would be easy for me. Tag map as a w1 dot adverb. So what we're gonna do now, we're gonna create the lematizer function over here. LMTZR equal to coordinate lemmatized list equal to, okay, so RMV for I in RMV. So we are taking only not null values over here. Now we're gonna iterate it over there and we're gonna tag it for tag in NLTK dot POS tag. So it's gonna do the parts of speech tagging for me on our input cleaned data, which is RMB variable, which is in the RMB variable. So we're gonna lematize it. So LMTZR dot lematize. So we're gonna pass the token and tag map 0. So this is going to create a lemmatization for me, and we're gonna append it in this lemma.list. Lemma.list.append. We're gonna pass this lemma over here, and we're gonna return. Sorry, my bad. Return. We're gonna return this lemmatized list over here. So this is going to do the lemmatization for me. Okay, so now what we're gonna do is like we have something like greeting sentences. Suppose if user thinks something like hi, hello, welcome. So we want to give a direct reply instead of doing some kind of a Python stuff behind it. So let's create that function over here. So let me write a small thing over here. Welcome inputs equal to something like hi, hello, and something like good morning. So welcome outputs something like response. Hello, something like something. Hey, uh, what's up? What we gonna do? Define welcome user response. So for word in user response, suppose sorry, user response dot split word dot lower in if any of the user input matches this one. So what we gonna do is like we gonna return random dot choice from this welcome response. So if user print something like hello, hi, good morning, so we're gonna randomly return something from here. That's what the function does at high level. Now we are going to write a function which is a generate response, so which is going to generate the real chatbot response to our end user. So here we're gonna get user response, which is a user input basically. So next what we're gonna do, robo response equal to, we're gonna have something like this. We're gonna have sentence tokenizer send token. So this is where we have appended it, right? So if you look here, this will be somewhere over here. Okay, send tokens dot append. We're gonna append it. All user has asked for, we're gonna append it. Next, what we're gonna do is like we're gonna create the TF-IDF vectorizer by removing the stopwatch over here. TF IDF vec. Okay, so we have something like TF-IDF vectorizer which we imported. Let me copy paste it. TF-IDF vectorizer tokens equal to, see, we're gonna pass this normalize function. So whatever user input takes, it's going to be normalized. So what all data cleaning we are doing here, it will be taken into action in this piece of line. and we're gonna remove stopwords equal to English. So it's basically going to remove all the stopwords in GLSH. Okay. So next what we're gonna do is like we're gonna convert into a vector form. So that's what we're gonna TF-IDF equal to TF-IDF vector dot fit transform sentence tokens. So next we're gonna convert into a, now we're gonna identify something like a cosine similarity of it. So this is the piece of code linear kernel, so which is going to identify the cosine similarity of each and every word of this one, of the TF-IDF vector. TF-IDF minus 1 comma TF-IDF. So this is going to identify the cosine similarity. Once we found the cosine similarity, we need to identify the maximus of the index which is having some of the reasonable output. So once we perform the cosine similarity, we need to identify the maximum value of the related search. So it's arcsort. Yeah, once we identify the cosine similarity, we need to identify the maximum value of the matching index. So arcsort of 0 comma minus 2. This is what we're gonna do. Flat equal to, now we're gonna flatten it. Now we're gonna sort it. Flat dot sort. Once we have done with everything, now we're gonna take the latest matching like index from there. Record TF-IDF equal to flat of minus 2. So what we're gonna do is like if TF-IDF, if nothing is found over here, 0, or if something starts like tell me about. So if anything, if no match is found, or if something starts with tell me about in user response. So let me make it in a bracket, so else it might go errors over here. If any of the one condition is matching, now what we're gonna do is like we're gonna check in the Wikipedia. So we need to print checking in Wikipedia page. So it's gonna do a internet search in the Wikipedia, all the Wikipedia pages, and it's going to return the response. So what we're gonna do is like if user response, then robo resp equal to Wikipedia data of user. We will write the function below. So we're gonna look into the Wikipedia for this. So what this function gonna do is like, so let me write the function now. Define Wikipedia, and we're gonna pass this user response over here. So what we're gonna do is like we need to look whether the user has asked for this tell me about. So we're gonna do the regular expression over here. So re dot search. So we're gonna do something like tell me about. So if user have asked for tell me about and he has printed something on the input on the user response or input, whatever it is. So we need to see whether this particular keyword is present. So what we're gonna do, we're gonna check it. I'm gonna write in the try catch block. So if regex topic equal to regex dot group of one, which means it's going to identify, suppose tell me about Abdul Kalam, so it's going to take that word Abdul Kalam alone from here. So what we're going to do, wiki equal to wk dot summary. So it's basically going to look in the Wikipedia page. So it's an inbuilt Python package on the basic, on the topic which user have asked for, and we're going to return some of the sentence, like top three sentences from there, and we're going to return wiki over here. So in case of any exception, except exception C. So what we're gonna do is like print no wiki content is found. So basically, if TF IDF we are unable to find anything in the given document, the sample data, or if the user types something like tell me about, then we will be doing a Wikipedia search. Okay, so this has been done. So robo response, it we will get over here, and let us return the robo response. Return robo response. Next, what we're gonna do is like else. Suppose if user in the else loop, what we need to do is like robo response equal to sentence tokens of that particular index. And we're gonna remove this particular thing from here and response. Okay, so we have written with all the logics. Now let us write a simple interactive environment where we used to get the user input and look into the Wikipedia and return the output over here. So let me write something like flag equal to true. Print something like my name is my name is Wikibot, something like this, Wikipedia bot or something like this. So what we're gonna do, while flag, it's gonna go in an while loop infinite times of thing. So we're gonna get the user input. So we're gonna get the user input. Now what we're gonna do is like, so we're gonna convert into a lowercase because we have trained our model in the lowercase. So once after converting into the lowercase, we're gonna check if user input not in any of this combination like by or something like this, thanks, something like this. So if any of this combination occurs, mhm, what we're gonna do is like we're gonna say flag equal to false. We're gonna come out of the loop actually, false, and we're gonna say print thanks for using Wikibot, something like this. Else if user haven't given any of this combination, then what we're gonna do is like we're gonna look into the welcome thing. So when I say welcome thing, this is the welcome inputs, right? So something like this. So what we're gonna do is like if welcome response, like welcome of user response, so whether user has print some entered something like hi hello or something else, then what we're gonna do, not equal to none, then we're gonna return it actually in chatbot. We gonna like we name it as wikibot. So it is gonna say something like welcome user response, welcome user input, user input, right? Then it is been done. So in case if it is not there, then what we're gonna do is like else print and double quotes wikibot. We're gonna do wikibot and we're gonna type in equal to, oh my bad, it should be in small case, in equal to, we're gonna print the generated response over here. So print generate response on user input. So basically what it's gonna do is like goes to the generate response function and it adds into the sentence token just for our tracking purpose. Then it is going to do the normalize. So when I say normalize, what it's going to do is like it is going to remove the unwanted punctuations and it is going to remove some kind of ASCII values and make it into the proper format and remove some kind of junk characters in it, and we're going to identify the parts of speech and we're going to do the lemmatization on top of it, and we're going to return the lemmatized text. Actually, on the lemmatized text, we're going to remove the stop words. After removing the stop words, we're going to have the tf idf vectorizer performed on top of it. So this vectorizer, that's what we are doing the fit transform over here. Once we have done these things, so what we're going to do is, like, imagine there is a word like artificial intelligence, and in the Wikipedia page there is some description given about artificial intelligence. It tries to match what is, if you ask something like what is artificial intelligence, whether this particular word is matching anywhere in the Wikipedia, it tries to capture that particular sentence. So that's what we are doing. So we are trying to get the cosine similarity between the input and the what is been in the tf-idf. Then we're going to maximize it and we're going to return that particular sentence alone. So that's what we are doing over here. Print user response. So then what we're gonna do is, like, we're gonna remove that from here. Sentence tokens dot send tokens dot remove user response. So we are adding it over there and we are removing it over there. So that's it. So if any of the things is not matching, what we're gonna do is, like, flag equal to false, and we're gonna type something like wikibot says. So we have done with the logic. So let me run this piece of one. Okay, this is. So we need to give, sorry, right? So we need to give if user input matches some of the condition, like by, oh, not in, if user input. So we need to give something like this. If user input, then we gonna do something like this. Then if user input, again, let me write something like this. User input, not in by, yeah, thanks, my bad. Hmm. So when I print hi, it is going to remove, it is going to give some random text from the greeting text. When I print hey, also it is going to, it should give some random. Okay, it is returning none. It's fine. I give hey over here, right? Oh, sorry, it's hello. So when I give hello, my bad. When I give hello, it will give some random text over there. So now let me ask something like, what is human resource, which is there in my input text. So let me print what is human resource. Okay, list. So I should comment this, my bad. So let me comment this one. There is, yeah. So what is human resource? So it says indeed getting work done. Others is not. Each every human resource should possess. So okay, there is something like explain paternity leave. So there is something like paternity leave. So it is a male employee, right, if he is working in central government of India, something. So it is trying to look into the text which I have given in the input, and it is giving some response over there. So now let me try to search in the Wikipedia. So when I give something like what is that, tell me about, so when I give something like tell me about, then it should look in the wiki, right? So let me tell me about artificial intelligence. So when I type something like this, it's checking the Wikipedia, it's directly connecting to the internet. So it's taking the summary of the wiki and it is trying to print it. So okay, something like tell me about SpaceX. Okay, looking into some other wrong thing. Continuum containing position, direction, physical. Okay. So let me ask one more. So what? Tell me about. Okay, tell me about something like Swami Vivekananda. Yeah, so it gives us some text about Swami Vivekananda. So this is some kind of a basic chatbot which you can build in your organization for some kind of other queries. So it is kind of a lightweight model. So thanks for watching the video and happy learning.